Hello friends, welcome back to Aurab Associates. From today, we are going to start ETABS building design series tutorial for a 7-storied building. This is the ground floor plan and this one is 1st to 6th floor plan. From these two drawings, we have prepared ground floor roof beam layout plan and 1st to 6th floor roof beam layout plan. Both are similar, so we can use any of these for preparing grid line distances for X and Y direction. Here you can see that in X direction we have A to H grid and in Y direction we have 1 to 7 grid, and these are the distances which we have to input in ETABS. This is the chart which we will follow in ETABS for modeling, analysis, design, reanalysis and detailing. Step 1. Open new file, select design code, open new model, then edit grid data and story data. Let's go to ETABS, file, new model, use built-in settings. Here I will use ACI 31814 code for concrete design, others will remain same. Then press OK. Custom grid spacing, edit grid data, display grid data as spacing. Here in X direction we have A to H grid, so we have to add some more grid ID in X grid data. So we have added grid data up to H, and for Y we have to add grid ID up to 7. Okay, now we have to input spacing, which I have already noted down. So let's input 11 feet 11 inch, that means 11.92, 10 inch 0.83, 6 feet, okay, 10 inch, that means 0.83, then 7.92, 7 feet 11 inch, 9 inch, that means 0.75, 10 feet 8 inch, that means 10.67. Last one will remain 0. Then for Y direction 3 feet 4 inch, that means 3 feet 3.33, 8 inch 0.67, 17 feet 9 inch, then 5 feet 6 inch, 5 feet 5 inch, then 11 inch. 11 inch 92. Last one will remain 0. Here from AutoCAD I have inputted the spacings. Okay, 11 feet 11, 10 inch, 6 feet 10 inch. Okay. Then press OK. Now come to story dimension. Here I am taking bottom story height as 8 feet, typical story height 10 feet, number of stories. Here this is a 7-storied building, but initially we will model only 2 story, then we will replicate story 2 up to story 7. Okay, then press OK. Here you will get 3 windows. Okay, one is Model Explorer, one plan view and other one is 3D view. Okay, now go to option, graphics mode, standard graphics. Okay, because we are habituated with standard graphics. By default you will get DirectX graphic. You can convert it to standard graphics. Okay, save this one. Now second step, define materials like concrete, rebar, etc. You can modify the compressive strength or yield strength of rebar material, which we will discuss in our class. Okay, so go to define material properties, add new material, concrete. By default, ETABS gives us some grade of concrete like 3000, 4000, 5000. Okay, but if we need to define 3500 psi concrete or 4500 psi concrete or 5500 psi concrete, what we have to do? Let me show you. Suppose initially we can select f prime c equal to 3000 psi. You can select any one, then press OK. Suppose we need to define 3500 psi concrete, so just write down here 3500. Okay, this is just name, nothing else. Then you have to modify modulus of elasticity. Okay, we know for concrete the equation of modulus of elasticity equal 57000 root over f prime c. Okay, so if we need to calculate 57000 root over 3500 equal, so we get 3372,165.476. Okay, 3372,165.476. Okay, then we have to modify property data. Okay, here by default, though we have selected 3000 psi concrete initially, ETABS will provide you data for 3000 psi. Okay, now you have to input here 3500 psi. That's all. So you have to make change in two location, that is modulus of elasticity and design property data here. Okay, press OK. Now I need to add rebar material, so add new material. This time I am selecting rebar. Then this time I am selecting rebar. Then by default you will find 3 grade of steel, that means 40 grade, 60 grade, 75 grade. Here I will use 60 grade steel. Press OK. But if you need to use 72.5 grade steel, that means for 500 W steel, what you can do? You have to just take a property of 75 grade steel, then press OK. Then design property data, here you will change minimum yield strength 72000 psi. Okay, other may remain same, but here I am using 60 grade of steel. Add new material, just 60 grade of steel. Okay, then press write rebar 60. Okay, other will remain same. Okay. Next step, define section properties of column, beam, slab, stair, shear wall, etc. Okay, go to CAD file. Here we have columns of sizes like 12 by 20, 12 by 25, then 15 by 20, 15 by 35, 12 by 30. Okay, also we have a shear wall of thickness 10 inch. Okay, then in this plan, okay, in this architectural plan, we can see that they are interested to use beam of width 10 inch, but for a structural analysis we will provide minimum 12 inch width beam. Okay, and we will consider the beam thickness as 21 inch. Okay, so let's go to ETABS, go to define section property, frame section. You can delete multiple properties by selecting here, delete selected property, then select all except only one property, then delete them. Okay, you can delete this one after defining at least one new property. Okay, so go to add new property, select concrete. See here, initial I am defining column 12 by 20, then material 3500, width will be 12, depth will be 20. Okay, 12, 20. Here also 12F by 20. Then go to property modifiers. Here I will change the moment of inertia about axis 2 as 0.7 and moment of inertia around axis 3 0.7. That means we are considering cracked section of column. Okay. By doing this, we are considering cracked section of column. Okay. Then go to reinforcement. Here just change reverse 60 and reverse 60. That means longitudinal bar reverse 60, confinement bar or tie bar reverse 60. Okay. Then press OK. Select OK. Now we can delete this one. Delete property. Then take add copy of property. C, or that means column property 12 by 25. Here just put 25. Other will remain same because we have copied the previous property of 12 by 20. Okay. We don't need to change here again and again. Just take the copy of previous one. Then press OK. Then add copy of property. C 15 by 20. Here use 15, 20. Just press OK. Add copy of property. C 12 by 30. C 12 by 30. Then press OK. Next one, add copy of property. C 15 by 35. Go to 15 by 35. Okay, that's all for column. Then define beam. Add new property. Just go to concrete rectangular section. Here name it beam or B 12 by 21 inch. Material will be concrete 3500. Width will be 12. Depth will be 21. Now in property modifiers, moment of inertia about axis 2 will be 0.35 and moment of inertia about axis 3 will be 0.35. That means we are considering cracked section of beam also. Okay. Then go to reinforcement. Here you have to select M3 beam design, longitudinal bar reverse 60, confinement bar reverse 60. Here you can change the centroid of top bar and bottom bar, but I feel that's more than enough. Okay. Then press OK. Press OK. Now you can take another copy for landing beam. Okay. Landing beam. We will take the section as 12 by 18. That means depth 12 by 18. Other will remain same automatically or being copied from the previous one. Fine. Press OK. Now we will define slab section property, slab section. Here go to add new property. Slab 6 inch 2-way. Then select slab material as concrete 3500. Now in modeling type you can see that there have shell thin, shell thick and membrane. We will select membrane here. That means in our structure slab will not take any moment or vertical load. Okay, it will just resist horizontal forces or lateral forces. Okay. Now here one question may arise if we need to consider our slab as shell. In that case, when we should take shell thin and when we should take shell thick. Let me make it clear. If the thickness of your slab is greater than span length divided by 10, in that case you have to consider your slab as shell thick. If the thickness of your slab is less than span length divided by 10, in that case you have to consider your slab as shell thin. Basically the limit is 1 by 5 to 1 by 10. Hope you can understand. Basically the limit is 1 by 5, that means L by 5 to L by 10. But if we take L by 10, okay, in that case the limit becomes lower. Okay, so it will be helpful for us. You can consider any mid value between L by 5 to L by 10, but here I will consider L by 10. Okay, so let me show you a practical example. Suppose we are defining slab thickness for this span, okay, for this panel. Okay, in that case you can see in y direction we have a clear span of 10 feet 3 inches, and in x direction clear span is 10 feet 11 inches. Okay, now that means we can take this one. Now if we consider some more 5 inch from the center of beam, and this also for this side more 5 inch, then it will become 10.25 plus 0.83. That means 10.25 plus 0.83, that means 5 plus 5 equal to 10 inch. In that case we get this one, that means 11 feet 1 inch. Okay, multiply this one with 12, that means we are converting the value to inch. Then we get 132.96 inch. Divide this one with 10. Okay, that means here our limit is 13.29 inch. Okay, now if you consider L divided by 5, in that case your limit will be, okay, your limit will be 26.59. so I am considering the lowest one. Okay, then now it's up to you. So here limit is 132.96 divided by 10, that means here our limit is 13.29 inch. Okay, now if we consider the thickness of our slab in this panel greater than 13 inch, greater than 13.29 inch, in that case we have to consider the shell as thick. If we take suppose like 6 inch, okay, which is less than 13.29, in that case we have to take the shell as thin. Now let me show you another example. Suppose we need to define this waist slab. Okay, waist slab. Here for this side length is 8 feet 5 inch, and for this side the length is 3 feet 10 inch. Fine, so we can take more 5 inch from here, but we are not considering. So for this one 3 feet 10 inch. Okay, multiply this one with 12, then divide this one with 10, that means span divided by 10 equals 4.5 inch. Now if we define a waist slab of thickness 6 inch or 7 inch or 8 inch or 9 inch, whatever, I just need to say if the thickness is greater than 4.5 inch, in that case you have to consider the waist slab as shell thick. Okay, then go back to ETABS. Here we are considering our slab as membrane. Okay, we are not considering here any shell, that means our slab will take lateral forces only. Okay, now if we consider slab as membrane, we get another new option, that means we can use one-way load distribution, which is not available for shell. Okay, now consider the slab as membrane. Then we are considering here slab 6 inch two-way, so we will not check mark here, just change the thickness as 6 inch, press OK. Now take copy, add copy of property. This time I will define slab 6 inch one way. Fine, concrete 3500. This time I will use check mark in slab in special one-way load distribution. Now all are okay. Fine. Now we can take more properties that copy, like landing slab 6 inch. This will be also one way, so that's fine. Then define waist slab, add new property. or add copy of property, waste slab. Here I will take 9 inch thickness because we can't model riser in ETABS, so I will take a greater thickness, that means 9 inch. Though we are considering membrane, there is no chances of using shell thin or shell thick. We will just use a one-way load distribution because our one-way slab, waste slab will be one way in x direction and the landing slab will be one way in y direction. I will show them during the time of modeling. So just press OK here. We can delete this property. Okay, slab 1. Okay, we can delete them. Okay, then go to define again. Define section property, wall section. This time go to, we can modify this one, so go to modifier / show property. I will define lift wall. Okay, here I have shown you that the thickness of our lift wall is 10 inch. Then from here select concrete 3500. This time we can't consider this one as membrane. We have to consider this wall as shell. Now, is this shell thin or is this shell thick? Let me show you. Here, let me delete them. For x direction, clear span is 6 feet and for y direction, clear span is 5 feet 6. So, we can consider 5 feet 6. From this side we can take 5 inch and from this side we can take more 5 inch. That means 5.5 plus 0.83 inch. 5.5 plus 0.83 inch. So divide this one with 10. Okay. So you can see, okay, divide this one with 12. That means taking to inch. That means 7.5 inch. But the thickness of our lift core is 10 inch. That means greater than 7.5 inch. That means we have to consider this lift core as shell thick. Let's find now. Okay, shell thick. Here I will provide 10. Now you have to change the modifiers. If we consider the wall as cracked, okay, in that case you have to change the modifier like this. Here F11 will be 0.35, F122 will be 0.35. No need to change this F12 value. Then go for M11, M22 0.35, M12 0.35. If you need to consider your wall as uncracked section, you have to provide here 0.7, okay, instead of 0.35. Okay, then press OK. Here I am considering cracked section of lift core. Press OK. Shell thick 10 inch. Okay. Then we have to add another property for spandrel or coupling beam. That means go to add copy of property. Name this one as spandrel 10. Okay. This one also consider this one as shell thick. Then take this one 10. This time also here modifiers will be same. Okay, that means we are considering cracked section of the spandrel. If you consider uncracked section, in that case you have to provide here 0.5 instead of 0.35. Okay, press OK. Okay. So today we have completed up to step number 3. In next class we will go for step number 4. That's all for today. See you in the next tutorial. Thank you.